There are rich gold ores out there to be found, but they have a variety of different kinds of appearances. But that means that some of them haven't been found. If you think everything looks like a quartz vein with gold in it, I'm going to change your mind in this video. I have a friend who was prospecting on one of his claims and found a hidden and undiscovered gold vein system, and it doesn't look like your standard quartz vein, but he's taken out literally pounds of gold out of that in the last couple of years. Does taking out pounds of gold sound like something good to you? It sounds good to me too. So let's take a look at gold ores up close. We're going to get right in there and really examine what the different types of gold ore look like. Even quartz veins, which you may be familiar with, maybe not, but even quartz veins, they don't all look the same, not even close. And you know, it's the fact that they don't all look the same, and some people are looking for a certain thing, that there are quartz veins out there and other gold deposits that haven't been found. You could be the person to go out there and find them. You might be out someday prospecting, maybe panning, maybe just hiking, maybe you're out hunting or just exploring the outdoors, and you see something unusual. You know, if you just say, oh, that's kind of different, and walk away, you may have just walked away from pounds of gold. So if you watch this video, you will learn what a lot of different types of gold ore look like. And by understanding that and having that knowledge locked away in your head, if you stumble upon something really good, it may benefit you and you may be able to get the pounds of gold you just would have otherwise accidentally walked by. So let's dig in this video and really examine different kinds of gold ores. Now, some gold ores do have visible gold that you can see with your eye right there. And of course, those are going to be the kinds that are easiest to recognize. But some valuable gold ores don't have any real visible gold. And in fact, the ore zone that my friend discovered that I mentioned, he's taking pounds of gold, it doesn't have visible gold in it, not unless you pan it or do other things. The gold particles are kind of small, and so, you know, if he crushes them up and processes them, then he gets some really nice gold. But if you were to just look at that stuff and say, well, I don't see any gold in it, and toss it out, you would have walked away from that find that he made, that he's taking pounds of gold out of. Now, he's done a lot of work, and when he did it, when he first found it, he found something that looked interesting. He crushed up a sample, and you know, it showed that it had some real nice gold in it. So that was how he got onto it. But you know, you got to remember that, you know, really even pretty rich gold ores may only have an ounce of gold in a ton of rock. And so it's easy that if you have a specimen of rock in your hand, I don't see any gold in this, it's worthless. Well, that's not necessarily true. Like I say, you could look at stuff and, you know, just see nothing. So let me show you what my friend's ore looks like. I got a picture of it in a bucket, and you'll see it just doesn't really look like much of anything.
So here's that super rich ore, and you look at it and you can see there's some yellow iron oxides in this, but there's nothing in there that really looks like quartz, does it? And if you were to look at the pieces real close, there is some quartz in there, but it's basically almost like a fault gouge is what the material is. It's a material in a fault zone that's been all broken up, and there's little quartz in it. There's iron oxides, but when you crush this up, it's super rich gold ore. And so this is what I'm trying to explain, that, you know, not all gold ores look the same, and sometimes, you know, you can look at something and test it, and it might surprise you. And this is actually the deposit inside the hole that he's dug, and the light colored white material on the left is the footwall, and then the little vein zone is the stuff immediately lying on that footwall. And you can see it pinches and swells, and it's really only a few inches wide, but it's got some pretty good gold in it.
Now in this video, we're going to take a look at different kinds of gold ores from all over the world. Some that are rich and have lots of visible gold, others that may still be rich and may have, a couple of ounces per ton, and that's considered really rich gold ore. It's the stuff, the high-grade stuff that my friend works has, maybe 2 to, I think the best he's found is maybe up to 10 ounces per ton. But still, even at 10 ounces per ton, which is even high grade for him and high grade for anybody, and still 10 ounces per ton, that's a very little bit of gold in a whole lot of rock. So you gotta be able to recognize this stuff. And with the price of gold today, the price of gold being so high, even 1 ounce per ton, that's $3,000 per ton of rock. That makes that rock worth $1.50 a pound, which if you can collect bucket loads of material, then you can be making good money. When we take a look at the different ores, we're going to divide it up into groups. I'm basically going to divide it up geologically. Epithermal and orogenic or mesothermal are the most common and well-known types, but we're going to take a look at some other miscellaneous types, and then we're going to talk about tracing. You find a piece of rock that's loose and you think, oh yeah, where's the deposit that this came from? Well, we're going to talk about tracing. The loose pieces are called float by prospectors, and we're going to talk about tracing float to its source. We're going to talk about testing for free gold. So you find a rock, you think it might have gold in it. Well, how would you test it and find out? And then we're going to talk about assays like fire assays. And that kind of thing can really help you, understand what the gold or other deposits, silver, that sort of thing, that are in the rock. So let's dig in. We've talked about how we're going to divide this up. Let's dig in and get started with the epithermal ores. These are ores that are formed generally nearer to the surface, sometimes associated with like hot springs. Sometimes they may be a little bit below the hot springs. Sometimes there's not much surface expression, but still, these are ores that are formed nearer to the surface generally.
Now, epithermal ores are found in many western states and many locations across the world, Mexico and other places. But in Nevada, most of the ore, or much of the ore anyway, is of the epithermal type. And some of it has some really obvious gold, and some of it doesn't. This is actually fairly high-grade gold-silver ore. The black mineral is silver. You can't really see the gold visibly, but this is high-grade ore. Here's another example of some high-grade ore from the Comstock Lode up at Virginia City in Nevada. The black again is silver minerals, and this ore was assayed at more than 6 ounces of gold and more than 50 ounces of silver. So this is super high-grade rock, worth many thousands of dollars a ton, and yet there's not any visible gold. It just looks interesting and is well worth testing because the result is good. A fair amount of the gold from Nevada is rich in silver, and this is a characteristic of epithermal type deposits. This gold in this specimen, you can see it's not the normal yellow color of gold. It's kind of pale, and it's because the gold that you see here is very rich in silver. There's a good percentage, maybe 30% of this is silver instead of gold. The gold wires in the upper left of this specimen are so rich in silver that they look more silvery than yellow, but yet this is an alloy of gold and silver. It's probably closer to 50-50 or 60-40, something like that, with a lot of silver. And that's just a characteristic of a lot of epithermal systems. Now, I said a lot of epithermal deposits are formed comparatively near the surface, and sometimes the hot waters that are involved in forming these deposits actually make it to the surface, and you see hot springs like this one in northern Nevada. But a lot of times they don't, But even when they don't make it to the surface, or if they do, they make deposit, alter and change rocks. The rocks are changed by exposure to hot acidic waters, even down deep. And you can see bleached rocks very commonly associated with mineral deposits, somewhat like this. This particular rock is located about a quarter of a mile east of the famous Comstock Lode up at Virginia City. But this is volcanic rock, normally a medium dark gray in color, and you can see the light bleached material. It's been altered and bleached by exposure to acidic solutions that got in the cracks of the rock, and as it weathered when it was near the surface, actually produced sulfuric acid, which changed the rock. And so you have these altered types of rocks, and they're a very strong indicator that there are mineral deposits in the vicinity where you see heavily altered rock like this near the surface. Nevada is a land of huge open pits, and you can see this altered rock that just goes on forever. I mean, it goes on for miles. And here, this mine has been producing gold and silver for decades and is producing millions of ounces. And the alteration is where the mineralization is. Now, geologists divide up epithermal type deposits into two classes. It depends on how much sulfur is in the system. If there's a lot of sulfur in the system that creates the deposits, it's called a high sulfidation system. And if there's a lesser to moderate amount of sulfur in the system that drives the formation of the deposits, it's called a low sulfidation. And in general, like the Comstock is considered a intermediate to low sulfidation type of a system, and they still creates this area of altered rock. But the high sulfidation creates huge areas of altered rock and ore specimens like this. This is a super rich gold specimen from the Goldfield district in central Nevada. Now, the gold in Goldfield and a lot of these high sulfidation systems are very small grained. And you can see by this blow up, you see the gold, it's just in little tiny specks and little bits. It's precipitated out as very small pieces. But, there's huge bands of it, and it really adds up to a lot of gold in some of these ores. A lot of the ores at Goldfield were fabulously rich, and there were, many tons that were taken out that literally graded ounces per pound of rock that had so much gold in it. Now, most of the examples I've shown for epithermal so far have been from Nevada, but by no means is Nevada the only place where epithermal gold deposits are found. Certainly there are deposits in California, Arizona, New Mexico, Colorado, and elsewhere. This particular boulder was found in Summitville, a district in Colorado, and it's a good-sized boulder. And the gold here, it's estimated to contain more than 300 ounces of gold in this one boulder. Again, this is a high sulfidation type of system like I've been showing you from Goldfield. You can see the rock is super etched and altered. It's so altered it's almost like Swiss cheese, the rock. So, there are examples of these epithermal ores in many places. A number of rich gold mines produce some amazing pockets. Now, it looks like this lady's holding a pan full of pure giant gold nuggets, but these are really chunks of quartz that have an awful lot of gold in them. So it's not pure gold, but there's an awful lot of gold there. And then this lady is an employee. This is a big mine, the Round Mountain mine in central Nevada that's been operating for decades and decades. And they sometimes get on this really high grade stuff. And this lady, like I say, she got her picture taken, but it's the gold that belongs to the mine. But what I am trying to say is sometimes you can find some really rich pockets of super high grade ore around mines, and that's really, as a prospector, what we're looking for. Now, Nevada is a land with a lot of faults and a lot of broken rock, But that's what opens up space for gold-bearing veins to form. And this is a little vein that formed in a crack in a fault in a rock. And then after the vein formed, the fault moved again and more quartz and more gold was deposited. In this rock, you can see some kind of brown areas, and the brown areas in the center part are the rusted remains of pyrite. Here I did a little drawing to help explain it better. The original vein as it was formed is the part of the quartz between the two green lines, and that's what originally formed. But then there was additional movement on this fault, which opened up additional space, and then there was more hot gold-bearing and quartz-bearing waters that came through and deposited more quartz. And that's basically the quartz that's between the pink line and the green line. Now, the outermost parts that I've labeled C, that's the country rock, the host rock, the wall rock that the vein is in place between. But you can show how there's a couple of generations here of quartz. And a lot of times, not always, but it's a fairly consistent thing that the gold is going to be in the second or later generations of quartz. There's going to be more gold in the later generations than in the first generations. It's just a common thing.
Next, let's take a look at the orogenic or mesothermal type. Now, these are related to mountain building. That's why they're called orogenic. It has to do with the words that mean that, but not in English. But it comes from mountain building, and they form deep, deep, deep in the ground. Literally a mile sometimes and more deep in the ground. And so it takes huge amounts and long times of erosion to bring that stuff up to the surface. You know, the mountain builds and lifts it up, material erodes off the surface, and eventually these deposits that were formed really deep down are exposed onto the surface, and they make for a lot of placer deposits and a lot of gold veins, and a lot of gold deposits, rich gold deposits. They're among the richest and most common types of gold ore that can be found around the earth. Let's dive in and take a look at them.
Here's a chart just to kind of compare some of these different types of gold deposits. You see that on the upper right-hand side, there's epithermal, and this is the type we were talking about just a minute ago. They form maybe a few hundreds to a few thousand feet deep. And then there's some different ones, the volcanogenic massive sulfide, the porphyries, and the Carlin type. Those are going to talk about as the miscellaneous type. And then at the bottom, like I say, the deepest is the orogenic. Here's a close-up of those lowermost types of deposits, the orogenic at the bottom. And like I say, they form in mountain building events, usually when tectonic plates, when the Earth's plates collide and one will get sucked under the other. The gold, along with other minerals that may be present, often are found in quartz veins. They're deposited in quartz veins. Now, when prospectors see quartz veins out in the field, this is usually what you're used to seeing. White quartz, stained maybe brown by iron oxides or stained maybe black by manganese oxides. And even if the vein does carry decent values, which this does, there isn't necessarily going to be good visible gold. You might be able to go over this specimen very carefully with a magnifying lens and look real closely and not see a speck of visible gold, even though it might have decent gold in it. Of course, this is the kind of specimen that we're really looking for, with lots of gold hanging out of it. And, your metal detector will easily pick something up like this. In fact, this will scream from a good distance. And this is what you're really looking for. There's a lot of gold in a specimen like this. This and the one we just showed, the quartz I just showed that didn't have any visible gold, are both mesothermal type deposits from the California Mother Lode Country. That's one of the big deposits of that in the United States, the California Mother Lode Country. Although not all orogenic quartz vein ore has gobs of gold in it, there certainly is a good amount that does. This specimen of super rich gold quartz is from the Homestake mine in South Dakota in the Black Hills. And this area, the Black Hills area, is also a orogenic or mesothermal type of gold deposit area. Sometimes ores will be found that look like this. The quartz vein that looks good, and iron staining, and you've got gold looking stuff on there. But unfortunately, this is not gold in the quartz. This is a big chunk of pyrite, of iron sulfide, or sometimes called fool's gold, in quartz. And you can see by looking at this, it might be easy for a person who wasn't experienced to mistake this kind of thing for gold. And even though there's a whole lot more barren quartz or quartz with just some pyrite in it, like I showed you, there are some amazing gold and quartz specimens from the orogenic or mother lode type deposits. This beautiful specimen is from Mariposa County at the southern end of the mother lode in California. The old mine dumps on the outside of the mine really are excellent places to hunt for gold in the old dumps from the operations, because they often cast out, unintentionally. They wouldn't cast out a specimen like this on purpose, but they often casted out some pretty good gold-bearing ore thinking that it was waste, and your metal detector will scream on a piece like this. And so, mine dumps on hard rock mines really are an overlooked spot that a lot of prospectors don't really take the time to search, because they can be really trashy as well as having some gold. And metal detecting the areas in placer areas around orogenic type deposits can yield some really good gold too. This big chunk of quartz had, I think, about 4 ounces of gold in it. It was just an amazing find. But it sounded off on a metal detector because the metal detector could see all the gold in that quartz. And sometimes these quartz cobbles get overlooked because people don't think about the fact that, hey, this quartz could have some gold in it. Detecting for quartz gold underground, it can be really dangerous, and so I don't recommend this at all. I really don't. But I have done some of it, and I have found some gold. Here I am way up in a stope in the working area where they take the vein. I'm probably 400 feet underground in this picture, from the surface anyway, but it's where they mined out the vein. And you can't see the gold in the piece in my hand, but the little piece I'm holding up does have some nice gold in it, and I chipped it out of the vein there that was next to me. But, this vein is only about 2.5, less than 3 feet tall, and so you're literally crawling around on your belly. And like I say, I don't recommend this. It's dangerous, and I don't do it myself very often. And orogenic deposits aren't always just about quartz veins. Sometimes the surrounding host rock gets mineralized too. This is the Golden Mile pit at Kalgoorlie in Western Australia, and this area has produced something like 60 million ounces of gold. And they're continuing to work this pit and continuing to expand it, and it's continuing to be productive and produce gold.
Next, let's take a look at the miscellaneous types. These are types that don't really fit into either of these two. Now, geologists have their own terminology for these types. They're a little less common, but the geologists have their own term. I'm not going to dig into the weeds and get into all the minor geologic terms for all these, but we're going to call them as a group miscellaneous. And so let's take a look at some miscellaneous type of gold deposits that you might come across.
So we're back to our chart here, and the ones we're going to look at and call miscellaneous are basically the intermediate depth. They're not as deep a formation as the orogenic, and generally not as close to the surface as the epithermal. Let's take a look. Here's a close-up of these miscellaneous types. The upper left is volcanogenic massive sulfides. These form actually on the surface of the ocean floor, so they end up being a little bit deeper than most epithermal, but they form these black smokers, and the black smoke that comes out is sulfide mineralization that accumulates. Porphyries and skarns are related to intrusions of granitic type rocks that, in the right situation, they can be rich in gold, but usually they're most important for their copper content. But many porphyry deposits produce huge amounts of copper and important byproduct amounts of gold. But there are porphyries and skarns that are chiefly valuable for their gold content. And then, of course, the Carlin type, these are usually in Nevada, but they're a very special and rich type of gold-producing ore that's highly unusual. So we're going to take a look at the three of these. Here's what those volcanogenic massive sulfide black smokers look like when they're forming. You can see there's just these spots on the ocean floor that shoot out this black smoke. Well, that smoke is actually little particles of lead and copper and zinc and some gold and silver minerals, and the smoke travels a little ways and then settles out of the water. And because they operate for many thousands of years, they build up a big thick layer of rich sulfide minerals that, like I say, is this volcanogenic massive sulfide, or VMS. And here's what the ore looks like. It's just a chunk of sulfide mineral. And like I say, these are usually rich in copper, but they can have very significant byproduct gold. There are a few of them that are valuable chiefly for their gold content. Next, we'll take a look at the porphyry deposits. These are deposits closely associated with intrusions of granitic type rocks. And in this piece, you can see basically the black lines are deposits of minerals rich in copper and silver, gold, and other things. And then the lighter color material is just the rock host that hosts these little fractures. And they're not big veins. It's just basically a whole area that's mineralized with these little fractures that are filled with rich, valuable sulfide minerals. This is what it looks like when it's unoxidized, as it formed. And this is what it looks like after it's sat near enough to the surface that oxygen and water from the surface come down into the rock. And you can see the blues and greens of the copper oxide minerals after the sulfides have been oxidized. Next, I want to talk about the Carlin ores. These are extremely important, and they don't look like anything in particular. You look at this specimen, it has a little over 1/10 of an ounce of gold per ton of this kind of rock, but the gold in it is all microscopic. If you crush this rock and panned it, pan the result, you wouldn't see any gold, because literally the gold is so small you need a microscope to see it. And so this is a huge amount of gold is produced by this method in Nevada. There are large deposits and giant open pits. And because it doesn't look like anything that you would recognize, it's not a quartz vein, it's not some other type of well-known deposit. It doesn't oxidize to produce copper stains and that sort of thing. It was ignored, and the big deposits of this weren't ever discovered even in Nevada until the 1960s, 70s, and 80s, and even into more recent times. Like I say, the deposits of this kind of rock tend to be huge and involve vast amounts of rock and produce huge amounts of gold. This is one of the Carlin pits in Nevada, and you can see it's gigantic. And these big mines produce big amounts of gold. Nevada literally produces multiple millions of ounces of gold every year.
Next, let's take a look at tracing float. So you find a piece of good-looking rich ore. You test it. You find that it does have some pretty decent gold in it. But you found maybe one piece or 2 or 3 pieces or 4 or 5, and you want to trace it back to the source. Well, where did this stuff come from? Well, there's a special technique for doing that. Let's take a look at that technique right now.
Now, here's a diagram that I did up for tracing gold up to a pocket source in a vein uphill, but it works just as well with tracing a quartz vein. With the gold, of course, you have to take pan samples and test each, do little holes and test each section as you're working your way up the side of the hill. But with quartz, you can actually kind of look on the ground and see the float quartz, and if there's more and more and more as you go uphill, you're indicating that you're getting close to the source. And the same thing too, decided where to turn uphill as you're going up a stream, and maybe you start seeing this angular float quartz, and you get to be more and more, and then eventually you kind of reach an end of it. Well, when you reach the end of it, you got to kind of turn around a little bit and go uphill. On one side or the other, it could be on either side of the stream. You just got to look for the float quartz and see which side it's on. That you trace it uphill, uphill, uphill until you get a high concentration of this angular quartz, and likely the vein is very near there and you can start looking around. One of the downsides of hunting for quartz veins, though, is the thing that they can, and often, frequently, not always, but sometimes do get buried by soil. This is a road cut, so you see a cut through the ground, but below at the bottom there, that's a good 5 to 6 foot wide quartz vein. Something very obvious, you would think, but it's got 5 or 6 feet of soil on top of it, and so it's buried and no one can see it. Unless this road cut had been made right here, you would never know that this vein is here. And so sometimes, tracing quartz veins can be difficult in areas when they're covered with soil. You may only see just some of that float quartz down below on the side of the hill, but you may get up to the top and find no obvious concentration because it's buried.
Next, let's talk about free gold testing. And this is basically just a matter of crushing the rock to a fine sand type of size, carefully panning it, and weighing the rock beforehand and weighing the rock afterward, or weighing the gold that you get afterwards. And so it's, how much gold you get afterwards per pound or ton of rock. Next, let's talk about assays. We're talking about fire assays. This is the kind of assay that would be done by a lab, by an assay lab. And, if you guys have rocks that you want, you can leave in the comments, and I'll give you the address and phone number for the place that I use for my assay testing. Now, there's not a zillion assay offices throughout the United States. There's a handful of them here and there, mostly in areas where there are people interested in prospecting and companies that are taking samples out looking for ore deposits. Here in the Reno area, there's quite a few of them, but I've got people, where can I find one in New York? And it's like, yeah, you're not going to find one in New York. New York may have zillions of people, but it doesn't have zillions of mining companies looking for ore. So it's going to be in places like that. But like I say, if you need somebody to do that, you can leave me a comment and I'll give you their name and address. But it's a technique. It's been well known for years, and it's a technique that will find gold that you can't see in that home free gold test that I've just talked about. If the gold is too small to see, if the gold is microscopic, you're not going to be able to pan it. And so you would have to have a fire assay to determine how much gold is in the rock that you're looking at, if any. Now, finding gold is a skill, and there's a lot to it. Geology, understanding ore deposits, how to find gold, where gold deposits are, how to do research and all that kind of stuff. It's a skill. It's something that takes time to learn. And, I have more than 40 years experience plus a degree in mine engineering. And so I wrote a book. It's called Fistful of Gold. And I'm going to tell you a little bit more about my book in just a second. But also, I talked about free gold testing and assaying. You can crush stuff. And, the simplest sort of thing is just a mortar and pestle type of thing for crushing rock. And I partnered with an outfit called High Plains, and they do sell some of that stuff. And so I'm going to tell you a little bit more about my book and about High Plains right now. This is my book, Fistful of Gold. It's an encyclopedia of everything you need to know to go out and find gold for yourself. It distills down my 45 years of experience out in the field prospecting, as well as my degree in mine engineering. It's, like I say, an encyclopedia. There's a lot to it. It's over 250,000 words long, hundreds of pages with hundreds of illustrations, teaching you what you need to know about geology, about mining districts, about techniques of finding gold. It covers metal detectors, sluicing, panning, dry washing, high bankers, you name it, it's covered in there. It talks some about platinum and diamonds, but it's mostly about gold because gold is more widespread. It is not so much a book about where to find gold, but a book about how to find gold. Because even if you have a location where gold was mined in the past and you go out there, well, where should you look to be successful in your prospecting, to find the gold that's there? This is the book that's going to tell you that information. I spent most of 10 years writing this book, so I thought a long time about it. It's got, like I say, lots of information and lots of illustrations, and I've had results from people who bought it. It's available on Amazon, but I recommend buying it through High Plains Prospectors, and I'll put a link in the description for buying this book through them. They have a better price than Amazon, and I have a special deal that I'll tell you a little bit more about, where you can get a 5% discount from the price even with that. On Amazon, the book rates a 4.7 out of 5, which means that of all the people that have bought it, they've been really highly satisfied, and I think you, if you buy my book, will be just as highly satisfied as well. Now let's talk a little bit more about High Plains Prospectors. They're a prospecting shop, a mail order prospecting shop that I've partnered with. The deal is that I can get you a 5% discount, a coupon code, and I'm going to put the code to that right here. It's just Chris Ralph, all caps with no space between Chris and Ralph. You put that in there as a discount code and you'll get 5% off their already really good prices. I think it's a great deal where you win by getting a discount, I get a little percentage of that, and they get new business. So if you need prospecting supplies, High Plains is really the way to go. And I'll put information, like I say, in the description more about how you can work with them, because I'm working with them. They really are great guys, a great company. For even more information, I also have a website, and I'm going to show you my webpage and talk a little bit more about that right now.
This is my webpage. It's located at NevadaOutbackGems.com. You can Google it, or I have a link down in the description below. But there's lots of information here, miscellaneous stuff, pictures, some historic information as well, stories. It's got a lot of great fun stuff. You'll probably be interested in it.
Now, on all of my YouTube videos, I encourage you guys to ask questions. If you have thoughts, comments, suggestions for things that I ought to look at in my videos, things that you want to find out more about, and I answer 100% of my questions. There's not very many YouTubers out there that answer 100% of their questions. I'm one of the few. And so I will do my best to answer what you have. I mean, I only can write so much. Sometimes the answer is something where I'm going to recommend that you buy the book and read about it. I also ask that you subscribe to my channel, click the bell notification so that every time I come out with a new video, you'll be able to watch it. And like I say, I cover a huge amount of topics. I also have 250 videos that I've already done, and so you can go back through my catalog of videos on YouTube. I'm sure there'll be many videos there that you'll want to take a look at, especially if you have any interest in gold or platinum, diamonds, gemstones, geology, and that sort of stuff. My YouTube site is going to be right up your alley. So I'll see you again real soon. We'll be out in the field and back in the office at the whiteboard, and whether we're looking at gold or platinum, diamonds, gemstones, or other interesting geology, it's going to be fun. You're going to enjoy it, and we'll see you again real soon.